Welcome back to the Deep Dive. We are so glad you've joined us again.
Great to be here.
You know how we do it. We take your sources, we dive in, and we try to cut through all the noise to really find out what matters for you.
That's the plan. We're kind of like your guides through the maze of research, trying to get straight to the core findings and what they actually mean.
And today, we're tackling a really important topic, one with big implications for the environment and public health, too. We're looking at heavy metal contamination in Mexico.
Yeah, and the source material we're digging into is this really comprehensive review paper. It just came out in 2025. It's a massive piece of work, pulling together research from decades.
Decades, really? How far back does it go?
It covers studies published over 30 years. Think about that. From 1992 all the way up to 2022. And the authors specifically looked for research on heavy metals in, well, everything, soil, water, sediments, right across Mexico.
Wow. Okay, so our mission today is to unpack all of that. We want to figure out, based on this huge review, where is this contamination happening most? What's causing it? And maybe most critical part, what are the health effects for people living there, according to the experts who put all this data together?
Exactly. It's about boiling down 30 years of science into a clearer picture for you.
It sounds like a really valuable review.
Oh, it is. A crucial snapshot, really.
Okay, let's get into it then. Maybe we should start with the basics for anyone who's not quite sure. What exactly are heavy metals, and why are they such a problem, environmentally speaking?
Good place to start. So heavy metals, or HMs, they're actually naturally occurring elements. Some, like, zinc or copper, we actually need them in tiny amounts for our bodies to work properly.
Right, trace elements.
Exactly. But the scientific definition, the one used in this paper anyway, generally refers to metals with a higher atomic number, usually over 20, and they're dense, like over 5 grams per cubic centimeter.
So they exist naturally, but the problem comes when the concentrations get too high.
Precisely. That's when they flip from potentially useful, or at least harmless in tiny amounts, to quite toxic. And what makes them a real headache for the environment is how they behave.
How so?
Well, unlike some pollutants that might break down over time, heavy metals, they just don't. They're persistent, they stick around, they build up in the soil, they get into the water, they settle down into sediments.
There they can get into living things.
That's the issue. They can be absorbed by plants, then eaten by animals, and they just move up the food chain, accumulating as they go.
So they build up in the environment and in organisms. They don't just disappear.
Exactly. The paper even mentions the global picture, like millions of contaminated sites worldwide, hundreds of millions of hectares of soil affected by metals like arsenic, cadmium, lead. It's a huge global problem, causing serious damage to ecosystems.
And this review specifically covered studies from 92 to 2022. You said 22 different heavy metals.
Yep, 22 specific HMs, and they looked across all sorts of environments in Mexico: farms, industrial zones, cities, rivers, lakes, the sea, sediments. It's incredibly thorough.
Gives us a really broad view over a long time.
It does, a very comprehensive look.
So now the big question. Based on all those studies reviewed, where is this contamination actually showing up the most across Mexico?
Okay, so the main goal of the paper here was to pinpoint the states where studies reported heavy metal levels actually exceeding the official limits.
The safe slams.
Right. They used the Mexican government standards where available, like NOM 147 for soil, NOM 127 for water. But for metals or places where those Mexican standards don't exist.
Which we'll get back to.
Yes, definitely. They use international guidelines from the WHO, FAO, EPA, organizations like that as a benchmark.
And what did they find overall? Is it localized or?
It's widespread, very widespread. Looking at the compiled data, they found studies reporting heavy metals over the limits in soil in 25 states.
25, wow.
In sediment, 26 states. And in water, also 26 states.
That's almost the entire country has documented instances of heavy metals exceeding limits in something soil, water, or sediment over that 30-year period.
Pretty much, yes, according to the studies reviewed.
Were there any states that kept popping up across all three? Soil, water, and sediment as having problems reported more often?
Yes. The review highlighted a few states that appeared most frequently in the studies reporting levels above the limits across all those environments. Those were Guanajuato, Michoacán, Guerrero, Sonora, Zacatecas, and Quintana Roo.
Okay, so those 6 states seem to be hot spots based on the frequency of reports in the literature.
Based on the published research compiled here, yes. They seem to have the most documented issues consistently reported across soil, water, and sediments.
Let's break that down a bit. What about soil specifically? What did the review uncover there?
All right, focusing on soil. The earliest reports they found were from 1992. The number of studies published seemed to peak around 2019.
And which metals were the most common culprits in soil?
The ones reported most often over the limits were lead, that was number one. Then copper and zinc were pretty much tied for second. After that, it was chromium, iron, nickel, cadmium, manganese, arsenic, and mercury, in that order of frequency in the reports.
And the paper gave some examples of just how high those levels can get, right?
Yeah.
I remember seeing some pretty shocking numbers.
Oh, absolutely. Really striking examples. Like in San Luis Potosi, some studies reported arsenic levels of, get this, 17,384 milligrams per kilogram, and copper at 7,200 milligram kilograms.
17,000. How does that compare to the limit?
Well, the Mexican standard for arsenic in soil varies by land use, but it can be as low as 22 milligrams. So, yeah, we're talking potentially hundreds of times higher than the standard in some spots.
That's incredible.
And it wasn't just there. Coahuila had reports over 760 milligrams for cadmium, Nuevo León over 21,000 milligrams for lead, Chihuahua over 21,000 milligrams for zinc. These are vastly higher than typical background levels or regulatory limits.
Just staggering numbers. Did the review highlight which states had the most different types of heavy metals exceeding limits in their soil?
Yes. Zacatecas came out on top there, with studies reporting 9 different heavy metals above standards. Nuevo León followed with 8, and Chihuahua with 7.
And this brings us back to the standards issue, right?
Exactly. The paper makes a point of saying that the official Mexican soil standard, NOM 147, actually only covers a limited list of metals. But this review found studies reporting concerning levels of other heavy metals that aren't even on that official list.
So the research is finding problems that the current regulations don't even specifically address yet. That's a critical finding.
It really is a potential gap.
Okay, what about water? Similar story there.
Pretty similar, yeah. For water contamination, the first reports in the review period were from 1999, and again, the peak year for publications was 2019.
And the metals most often found exceeding limits in water.
Copper was the most frequently reported. Then cadmium and lead were next, followed by chromium and zinc. After that, arsenic, manganese, iron, mercury, and nickel.
Any standout examples of extreme concentrations found in water studies?
Definitely. Zacatecas again showed up with some very high reported values, like 2,500 milligrams per liter for both chromium and zinc, and 85 milligl for mercury.
Okay, wait, 2,500 milligl for chromium. What's the drinking water limit?
The Mexican drinking water limit for chromium is 0.05 milligl. For mercury, it's 0.001 milligl.
So these reported levels are thousands, maybe tens of thousands of times higher than the drinking water standards in those specific study locations.
In those reported instances, yes, it's quite extreme. Sonora had studies reporting 1,200 milligl of copper, 75 milligl of lead. Puebla had reports showing cadmium at almost 4,000 milligl, nickel over 22 milligl. Guanajuato had iron reported over 3,700 milligl.
Again, just massive numbers compared to safe levels. Which states had the highest number of different metals exceeding water standards according to the review?
Guanajuato had the most, with studies reporting 14 different heavy metals exceeding limits in water. Michoacan was next with 10.
And the standards issue pops up again here, too.
It does. Similar to soil, the paper points out that the official Mexican water standard, NOM 127, also only includes limits for a specific list of metals. The review shows many other metals exceeding international guidelines in Mexican waters, suggesting that standard might also need expanding based on the evidence.
Okay, so soil and water. Widespread contamination reported, sometimes at incredibly high levels, and potential gaps identified in the official standards. What did the review find for sediments?
Sediments are interesting. Studies started appearing in 1994, with peak reporting around 2013. The metals most often reported above limits in sediments were nickel, lead, and zinc. Those 3 were most frequent. Then copper, cadmium, chromium, followed by manganese, iron, and arsenic.
And where were the highest concentrations found in sediment studies?
San Luis Potosi again had some exceptionally high reported levels. Arsenic near 15,500 milligilligrams, copper almost 6,000 milligilligrams, antimony over 13,700 milligilligrams. Guerrero also had high reports, like cadmium at 781 milligilligrams and zinc over 4,500 milligrams in sediments.
Which states had the most metals reported over limits in sediment?
Guerrero and San Luis Potosi both had studies reporting 8 different metals exceeding reference levels in sediments.
And this is where that major regulatory point comes in, right?
This is the really crucial part flagged by the review authors, yes. Unlike soil and water, there is no official Mexican standard setting maximum permissible limits specifically for heavy metals in sediments. None at all.
Seriously. So all those studies finding high levels in sediments, what are they comparing them to?
They have to use international standards or guidelines for other countries or organizations because there's no specific Mexican benchmark for sediment quality regarding heavy metals.
So this review pulls together decades of research showing widespread high levels of contamination in sediments across many states, for which Mexico has no official standard.
Exactly. That's a major takeaway. It really begs the question, why is that standard missing when the contamination is so clearly being documented by researchers?
That is a huge point. Okay, so we know where it's happening, which metals are involved, often at alarming levels. The next logical question the paper tackles is, where's it all coming from?
Right. The review makes a clear distinction between natural sources, like volcanoes or rocks eroding naturally, and anthropogenic sources, the ones caused by human activities.
And the emphasis is on
the human activities. The paper states pretty strongly that these anthropogenic sources are the main drivers of the heavy metal contamination documented across Mexico in these studies.
Okay, so what are the main human activities identified as the sources in the, over 500 studies they looked at?
They identified several key ones based on how often they were cited as sources in the papers. Industry was mentioned the most reference in 455 studies.
That's the vast majority.
Yeah. Then came urban wastewater discharges, mentioned in 325 studies. Very close behind was mining in 323 studies. Then agriculture was cited as a source in 259 studies. Less frequent but still noted were fuel combustion in 95 studies and smelting in 15.
So industry, wastewater, mining, agriculture. Those seem to be the big four, consistently linked to the problem in the research they reviewed.
Definitely the most frequently cited sources across the board.
And which specific metals are most often linked to these activities?
The paper points to lead, cadmium, copper, zinc, arsenic, chromium, and nickel as the heavy metals most commonly released by these sorts of industrial, urban, and agricultural activities.
The review also gave some specific examples linking states, sources, and contamination, didn't it, to make it more concrete?
It did, which is helpful. For example, looking at industry as a source, the states with the most studies identifying it were Baja California and Guanajuato, 11 articles each. The paper mentions specific things like industrial discharges around Mexicali and Baja California, and it notes that parts of Guanajuato are even designated as an environmental emergency region, partly because of contaminated industrial water.
So direct links. What about mining?
For mining, Guanajuato and Sonora had the most studies connecting mining to heavy metal releases, 19 and 15 articles respectively. Both states have a long mining history, right? The paper highlights issues like the Canania mining area in Sonora with its hazardous abandoned tailings and similar problems with old gold and silver mine tailings in Guanajuato.
So the legacy of past mining is still a present-day source of contamination.
Makes sense.
And agriculture and wastewater.
For agriculture, Baja California and Sonora again showed up with a significant number of reports linking farming practices to heavy metals, 9 and 8 reports. Places like Hermosillo City and Sonora are noted as key agricultural zones, and the Mexicali Valley in Baja California is mentioned for contamination often linked to agrochemical use.
Pesticides, fertilizers?
Likely, yes. Things containing heavy metals as impurities or active ingredients. And finally, for urban wastewater discharges, Baja California and Veracruz had the most studies connecting wastewater to heavy metal pollution, with 9 and 8 reports each.
These examples really ground the data, don't they? It shows it's not just abstract contamination, it's tied directly to factories, cities, farms, and mines in specific places.
Exactly. It connects the dots between human activity and environmental impact.
Okay, so we've got the locations, the metals, the sources. Now, we need to talk about the bottom line, really. What are the documented health risks? What does this review say about the impact on people?
This is obviously a critical part, and the findings here are, frankly, quite concerning. The review is very clear. Toxic levels of heavy metals pose serious health risks globally. And crucially, these risks are documented and are affecting potentially millions of people within Mexico based on the compiled studies.
What kind of health problems were most frequently linked to heavy metals in the studies they analyzed?
The most common health issues that kept coming up in the research reviewed were things like cancer, damage to the central nervous system, the CNS, so brain and spinal cord, DNA damage, kidney problems, lung issues, and heart or cardiac problems. The paper actually tallied it up. Studies linked 15 of the 22 heavy metals they tracked to various health problems, or pathologies, as the paper calls them. And importantly, 10 of those metals were associated with what the authors termed the worst pathologies.
The worst pathologies. Which metals were those?
That list included lead, arsenic, cadmium, chromium, zinc, iron, manganese, mercury, copper, and nickel. So many of the metals we've already discussed as being found at high levels.
Can you give us some examples of the specific links found in the studies, like this metal linked to that disease?
Sure. Lead, for instance, was linked to the most different health problem studies, connected it to 17 different diseases. It was frequently associated with cancers, lung, stomach, bladder, plus CNS damage, kidney issues, and cardiovascular problems like hypertension. Studies also mention effects on the liver and how it can mess with DNA repair.
Okay. What about arsenic?
Arsenic was linked to 16 diseases in the reviewed studies. Primarily liver cancer, but also effects on the lungs, heart, skin, nervous system, kidneys, digestive system. Research highlighted how it can interfere with DNA processes and cause vascular and nerve damage.
And cadmium. You mentioned it was a known carcinogen.
Yes, classified as such by the IRRC. Studies linked cadmium to 14 diseases, including cancers of the kidneys, lungs, pancreas, breast, prostate, digestive system, also severe kidney damage, potentially leading to renal failure, and lung injuries if inhaled, say, from industrial dust.
What about some of the others, like zinc or chromium?
Zinc, surprisingly perhaps because it's essential in small amounts, was linked in studies to 14 diseases when exposure is high. Correlations were found with cancer, DNA damage, brain diseases, respiratory issues. Inhaling zinc fumes, for example, is known to cause flu-like symptoms. Chromium, especially the hexavalent form, chromium the 6th, is another confirmed carcinogen. Studies linked it to cancers, particularly lung, bladder, kidney, and others. Exposure through groundwater was linked to skin and digestive problems.
Mercury. Always hear about that one.
Mercury was linked to 12 diseases in the review, mainly cancers, CNS damage, and kidney damage. It tends to build up in the kidneys. Chronic exposure, according to the studies, causes neurological issues, problems with coordination, muscle weakness, speech, reflexes.
And copper.
Copper was linked to 10 diseases, things like DNA damage, cancers, digestive issues, CNS effects. Some studies linked it to genetic disorders like Wilson's disease, and even potentially neurodegenerative diseases like Alzheimer's and Parkinson's. High levels, especially combined with nickel, were associated with reproductive problems and liver toxicity in some research.
That paints a very clear and worrying picture of the potential health consequences based on the research. Did the paper also cite examples where human exposure was actually measured in these contaminated areas?
Yes, and this is really important because it moves from environmental levels to actual impact on people. For example, studies they reviewed found lead levels in children's blood in Guanajuato averaged 7.9 micrograms per deciliter. In San Luis Potosi, studies found levels of 11.6 and 8.3 no GDL.
And how does that compare to what's considered safe for kids?
The WHO and other health bodies recommend levels stay below 5 NGL for children, so these documented levels are significantly higher than the recommended safety threshold.
Showing direct exposure in children at concerning levels.
Exactly. And for arsenic, they looked at risk calculations called a hazard quotient. A value over 1 suggests a significant risk. Studies near mining areas in Sonora found 57% to 77% of children had arsenic hazard quotients over 1. In Zacatecas, it was at least 74% of children near mines.
So a clear, quantified risk for children living near those mining sites.
A documented high risk, yes. The review also mentioned other specific findings. Lead identified as a major risk factor from Atoyac River pollution in Puebla. Water from the San Juan Texco River in Guerrero, with its mix of manganese, arsenic, aluminum, and lead, was deemed unsafe for consumption or long-term use due to health risks. In Quintana Roo, analysis of urban drainage sediments indicated a high carcinogenic risk for people nearby, particularly from zinc and copper. And in Michoacan, studies directly linked high arsenic in well water in one town to observed increases in stomach problems, lung cancer, and skin diseases among the residents.
Those specific examples really hammer it home. The health risks aren't just theoretical. The studies compiled here show there are real documented impacts on people living in these contaminated regions of Mexico.
Exactly. It connects the environmental data directly to human health outcomes observed in these communities.
Okay, so let's try and sum this all up. This huge review paints a pretty stark but really essential picture of heavy metal contamination in Mexico over the past 30 years.
It really does. The main takeaways are quite clear, I think. The contamination is widespread, documented, and studies cover nearly every state. Levels are often extremely high in specific locations.
And the sources are primarily human activities industry, wastewater, mining, agriculture are the big ones identified consistently in the research.
Right. And maybe most importantly, the review brings together the evidence showing significant documented connections between this environmental contamination and serious health problems for people, including cancer, nerve damage, kidney disease.
Yeah, the paper really serves as a critical reference, doesn't it?
Yeah.
Pulling all that research together to show the state of play. The authors mention its value for researchers working on cleanup, but also for, well, for authorities and the public in Mexico.
Absolutely, for understanding the scale of the problem and, hopefully, for informing better regulations and actions, it lays down an evidence base.
A solid foundation built on decades of research.
Percent.
Well, that brings us to the end of this deep dive. We really hope breaking down this major review paper has helped you, our listener, get a clearer understanding of the key findings on heavy metal contamination in Mexico based on the source you provided.
It's definitely a challenging situation that the research highlights, but knowing the facts, the scale of it, the documented risks, that's always the necessary first step.
And we really appreciate you bringing this significant piece of research to our attention. It was important to cover.
Highlighting these kinds of comprehensive findings is crucial, I agree.
You know, thinking about everything we've discussed, the widespread nature of this contamination reported over 30 years, the serious health impacts documented, and especially those gaps the review pointed out in the official standards, like the complete lack of one for sediment. It leaves you wondering, right? What are the most urgent steps needed now? How do we translate this mountain of research into actual effective action on the ground to protect people's health across Mexico?
That's the million-dollar question, isn't it? The research provides the what and the why. The next, much harder step is figuring out the how.
Definitely something to think about, prompted by these findings. We really encourage you to keep exploring this topic if it interests you. There's always more research, more to understand.
Stay curious, stay informed.
And we'll be back soon for another deep dive, digging into the sources you send our way.
Until then.